Hey there everyone, and welcome back to Math 7. So we've been talking about functions and relationships and how to relate different things from different information we're given, whether it be tables, graphs, or equations. So we're kind of continuing on with that whole format today. So today we're talking about rate of change and slope. So what a rate of change shows is the relationship between two changing quantities. And in our case, our changing quantities are x and y. So we can see in our table here how x is changing as we move, and then also how y is changing. So rate of change kind of tells us how they are behaving together. How is one affected by the other? So how we find our rate of change is we do the change in the dependent variable, or the y value, divided by the change in the independent variable, or the x value. So you can think of this as y over x, just like we found our m, our proportional constant, in multiplicative relationships. So just note, when a linear equation, which we have been playing with, y equals mx and y equals x plus b, is graphed, forming a straight line, the line represents a constant rate of change. So what that means is our line is changing by the same amount no matter what 2 points you're going from. So from this point here to this point here, its rate of change is the same as going from here all the way to here. It's changing at a constant amount as we go on. All right, so what is the rate depicted by the table? So remember, we're going to use our m formula to find that out for this guy. So we're doing y over x. So our first one, 80 over 2, well, that's going to reduce to 40 over 1. 160 over 4, well, I can reduce that down to divide it by 4, and we're going to get 40 over 1 again. And I think we can see a pattern emerging here because we have a multiplicative relationship. So what this means is that 40 is my rate of change. For every hour I'm driving, I go another 40 miles. So that is constant all the way through. So now let's look at graphs. So we're going to figure out how to find the rate of change on graphs. So now we're going to start talking about slope. So excuse me. So slope measures the steepness of a line. So this is the same thing as the rate of change. It's how steep is our line, how fast is our graph changing. So there's 4 different types of slope we can have. We can have a positive slope, where things are growing as we move forward. So as we move forward in time, our line is getting higher. There is negative slope, which means something is going, as we move forward in time, something is getting smaller. We have zero slope, which means there is no change in y as we go. So just a flat horizontal line is zero slope. And then we have undefined slope. So the reason we call that undefined is because if we calculate the slope, our rise is infinity, because that thing will keep going on for forever. And our run is 0, because we're not moving left or right at all. So we cannot divide anything by 0, so that's why we call it undefined. All right, so the formula for our slope is rise over run. So we have to, excuse me. So we have to rise before we can run. So how to find the slope of a line using a graph? So we're going to find any 2 points on the graph that we want, that we're worried about. And then we are going to count how many times we had to rise and put that, so we're going to make a fraction, so we're going to put that on the top. So our rise is our change in y, because that's our vertical change. And then we're going to count how many times we had to run in order to get from one point to the other, which is our horizontal change. So let's try that one time with this graph here. So we have these 2 points. So what we're doing is we're counting how many times we had to rise first. So we're going up. So 1, 2, 3, 4. So our rise in this case is 4. Then we got to count how many times we had to run to get across to that point. So run is horizontal. So we got 1, 2, 3, 4, 5. So our rate of change, or our slope for this guy, is 4 over 5. So it's really that simple. You just find 2 points on a graph, and then we count how many times we had to go up or down if it's a negative number, and then how many times we had to go horizontally. So that's it for slope today. Pretty easy to find. So we're just going to be taking a look at graphs, I'm pretty sure. Yep, that's all our assignment is just checking out graphs. So we're going to find the rise, we're going to find the run, and then we're going to tell what the slope is by making a fraction of rise over run. All right, so our assignment starts on the next page on Canvas. So go ahead and open that up. And you're given a graph. You don't have to redraw the graph for me. So if you just want to use your computer to count out your rise and your run to find your slope, that's all you need to tell me is the rise, the run, and the slope you get from it. So remember, rise is going on top, run is going on the bottom. All right, so as always, if you're having any troubles, email me, send me a message on Canvas, and I will reply to you as soon as I can. And yep, so don't forget your assignment, turn that in when you finish up, and then there's also an IXL to go along with today. Thank you, and I will see you guys on Thursday.